Hello again, this is the next lesson, which is Unit 1, Lesson 5. So this is going to be about solving quadratic equations. These are equations that have something like the one variable that has an exponent of 2. So it's going to be something squared. Okay, these are the things that cause parabolas as you studied in Algebra 1. So we're going to talk about those briefly because we also use those in some of the geometric things. Okay, once again, if you have any questions or anything, make a note of it so that you can be prepared to bring it to class tomorrow and ask your question before we start any kind of work. Okay, so let's take a look at what we got. Okay, definitions and concepts. A quadratic equation is an equation that can be put in this form: ax squared plus bx plus c equals 0, where x is a variable and a, b, and c are constants. In this lesson, we will review the following techniques for solving a quadratic equation. Okay, so what they're actually telling you here is a, b, and c are actually a and b are coefficients of the variable, and c is always a constant number. Okay, so let's take a look at some more. Okay, one of the ways we're going to talk about solving is by factoring, which comes directly from what we've talked about in the previous two lessons. Quadratic formula, this is something that should have been discussed. The one thing about factoring is if it works, it's quick and simple. The quadratic formula takes a little bit of work. And you can also use a graphing calculator, because actually what we're looking for is where does the parabola cross the x-axis. So if you find that, or another way to say that is when y is 0. Okay, so if you find those 2 points, then you know what the solutions to the equation are. Okay, so example 1, they want us to solve x squared plus 4x minus 12 equals 0 by factoring. Okay, so what we're going to do is write this down like this: x squared plus 4x minus 12 equals 0. Then if you can use the box method, or you can guess at it, which is what I did here, that gives me x plus 6 times x minus 2 equals 0. Either way, if you factor it using the box method, then it'll take you a couple of steps to get there, but you should end up with x plus 6 times x minus 2. Okay, what this really means is x plus 6 is actually a single number if you know what x is. X minus 2 is a single number if you know what x is. So what we're actually asking here is one number times another number equals 0 means that at least one of these numbers has to be 0, but it could be both of them. And so we'll solve it for both of them, because either one being 0 will cause a solution. So how you do this is you say x plus 6 equals 0. So you're saying what makes the first one 0 by doing that. Solve this by subtracting the 6 from both sides, so 1x is negative 6. Okay, now we're going to take the x minus 2 equals 0 case. So we add the 2 to both sides, so x is equal to 2. So the solution set for this particular quadratic equation is going to be 2, or negative 6, 2, because you should always write it in the order that it came in. Okay, so right, so you should have negative 6, 2 is your solution set. Okay, let's look at example 2. This one looks like it's going to be broken up into a couple of things. This one's a little bit more complex, so you couldn't just guess at it too easily. So we're going to write it down in the boxes like we did before. So with the 8x squared, it's going to go in the upper left box, and the negative 3 is going to go in the lower right. Okay, so then we're going to multiply those together to get negative 24x squared, and we know the sum has to be the middle term, which is negative 2x. So we need, what we're asking here is what two numbers multiplied together give us 24 that will also result in 2x. Okay, so that looks like it's not going to be 8 and 3, it's not going to be 12 and 2, and it's not going to be 24 and 1. So the only other thing left is 6 and 4. Okay, 6 minus 4 will give us 2. So since there's a negative on the 24x squared, that means either the 6 or the 4 has to be negative. But since the negative is on the 2 also, that means the bigger one has to be negative. So that means that the 6 has to be negative. So we're going to put a 6x in one box and a 4x in the other box. Okay? So now we're going to factor these, or find the greatest factor. So what we're going to do is take the first row. If you look at that, you're going to find a 2x in both of those. So they put a 2x out to the left. In the bottom one, there's not a common factor, so we're going to put a 1. Since the 4x is positive, the 1 will be positive also. Going up the columns, in this one, in the left column, you're going to find that the 4x is in common between both of those, so we put a 4x up here. And in the left and in the right column, that you're going to find that you have a negative 3 in both, or 3 in both of those. The box at the upper right is negative, so that means the 3 is negative. Okay, so this tells us that the factoring of this is going to lead to this, which is going to tell us these are our factors. 4x minus 3 times 2x plus 1 is equal to 0. So we're right back where we were a while ago. We need to know what makes 4x minus 3 0 and what makes 2x plus 1 0. So we just simply say the equation 4x minus 3 equals 0. Add the 3 to both sides, gives us 4x equals 3. Divide both sides by 4, so x is equal to 3/4. So that's one of our solutions. Okay, the other solution is going to come from 2x plus 1 equals 0. Subtract the 1 from both sides, gives us 2x equals negative 1. So x is going to equal negative 1/2. So the solution set for this particular quadratic is negative 1/2, 3/4. Okay? All right. Sometimes you can't factor a quadratic. So if you can't factor it, you will use the quadratic formula because that will solve all quadratics, even the imaginary ones. So, which I know you haven't gotten into yet, but we're not going to talk about them. Well, I just want you to know that there is such a thing. Okay? So the quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So we're going to use that over here. So we have x squared plus 10x plus 24. So our a here is going to be the 1 that's in front of the x squared. B is going to be the 10 that's in front of the x. And 24 is going to be our c. So that's what we got right here. A equals 1, b equals 10, and c equals 24. So now we plug it into our equation, which says x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so we put the 10 in for the b, so we have negative 10 plus or minus the square root of 10 squared, because that's what b is, minus 4 times the 1 that's a, and times the 24 that's c. And all that's over the 2 times 1, which is 2 times a. Okay, so this gives us negative 10 plus or minus the square root of 100 minus 96 over 2. So this gives us negative 10 plus or minus the square root of 4 over 2. The square root of 4 is 2, so that gives us negative 10 plus or minus 2 over 2, which leads to negative 10 plus 2 over 2. That gives us negative 8 over 2, which reduces to negative 4. Okay, and then that's going to give us the other solution, which is the negative of this. So what we did here is we took the plus and went down this side, and then over here on the right we're going to take the negative and go that way. So it becomes negative 10 minus 2 over 2, gives us negative 12 over 2. So the other x is negative 6. So the solution to this quadratic is negative 6, negative 4. Okay, example 4, they want us to solve 2x squared plus 3x minus 2 equals 0 using the quadratic formula. Okay, so once again, we're going to identify a, b, and c. A is the number in front of x squared, so that's 2. B is the number in front of x, so that's 3. And negative 2 is the c. Okay, so let's put our formula down. There it is. So we're going to plug everything in, so that becomes negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 2, and all that's over 2 times 2. X is equal to negative 3 plus or minus the square root of 9 plus 16 over 4. So x is equal to negative 3 plus or minus the square root of 25 over 4. Okay, since the square root of 25 is 5, we have x is equal to negative 3 plus or minus the 5 over 4. So this means one side is going to be plus 5, one side is going to be minus 5. So that gives us negative 3 plus 5 over 4, gives us 2 over 4, which is equal to 1/2. Okay, the other one is going to give us negative 3 minus 5 over 4, so that gives us negative 8 over 4, which gives us negative 2. So the solution to this is going to be negative 2, 1/2. Okay, quadratic equations are also easily solved using a graphing calculator by first graphing the quadratic function and then finding the zeros where it crosses the x-axis. Okay, so the zeros are going to be like this in the diagram. The first root is going to be over here on the left and the second root is over on the right. That's what R1 and R2 stand for. Okay, example 5. They want us to use a graphing calculator to find the roots or the zeros of y equals negative x squared minus 8x minus 10. They want us to make a sketch of the calculator display and label the roots. Okay, so what happens is if you look at your calculator after you do this, then you end up with this. Okay, so your parabola looks like this. It's opening down because there's a negative in front of the x squared. And if you use the calculator to find the roots, you can find the roots directly by pressing the keys and looking for them. Okay, one of them will give us negative 6.4495. The other one will give us negative 1.5505. Okay, there are special cases. Okay, so you need to be aware of this. You can have a double root. In other words, the parabola is tangent to the x-axis. This means that it only touches the x-axis at one point, which would be the vertex of the parabola. Okay, if it touches it in one point, then both roots are that one point. The other one is, well, it would look something like this if you graphed it. Okay, there's no solution. This means that the parabola never crosses the x-axis. So this means there are no real roots. However, there really are two roots, but they're imaginary numbers and we haven't talked about those yet. But to see an example of what one would look like, it would look something like this. Notice that it never crosses the x-axis or touches it. Okay, so that's basically what comes down to the special cases. The regular case, the general case is going to have 2 times that it's going to cross the x-axis, and those will be both of your roots. Okay, like I said one more time, if you got any questions, be sure you bring them up tomorrow when you get to class, and we'll be glad to discuss them before we go on then to any work. Thank you very much. Have a good rest of